why do I need decorators? Well, we've seen decorators before. It's this little commercial at that comes on top of a function and it does something. And I guess we've even seen decorators like static method or class method, or maybe we've seen some other decorators. But for the most part, we probably have a sense that a decorator is a function that takes a function and returns a function. Unfortunately, a decorator is not a function that takes a function and returns a function at all. Here's what a decorator really is. Well, this thing here is not a decorator. This thing here is not a function. It is let's actually change this here. This is a generator. So a decorator doesn't have to be a function. Decorator could be a generator. This thing here is a class that I'm using as a decorator. So a decorator doesn't have to be a function. It could be a generator, or it could be a class and gives an instance. This thing here is a nice little formulation for a memoizing decorator that wraps around a function and turns that function into an instance of a subclass of a dictionary, so that when you call this function, it'll turn the function call into a dictionary lookup. And if you are missing the key, it'll go and compute that key. But if you're not missing the key, it'll return it from the dictionary. So it shows that correspondence between a lookup table and a function very clearly, because a lookup table is just a dictionary. It turns a function into a dictionary. So this is a thing where it's not a function that takes a function and returns a function. It is a class that takes a function and returns an instance of that class. Well, hold on a second. This thing here is not a function. The target of a decorator doesn't have to be a function. This is a generator. This thing here is an asynchronous function. This thing here is an asynchronous generator. This thing here is a class. So a decorator is not a function. It's something that doesn't have to take a function, that takes something, and doesn't have to return a function, returns something. What the heck is a decorator in the first place? Well, if we think about it, when we look, and by the way, even that returns is something that we can raise concern with. This decorator doesn't return anything. This decorator returns a literal value. This decorator returns the function evaluated. A decorator is not a function that takes a function or returns a function. It's a lot broader than that. In fact, if we think about it strictly, a decorator is syntax in which a callable has some structure that is created with def or class, i.e. a function, a generator, an asynchronous generator, or a class, and that thing is passed in as the only positional argument to the callable, and the result of that callable is rebound to the name of the structure. In other words, we may know that when we apply a decorator like this is basically equivalent to taking this thing, which is any kind of callable, against this thing, which is anything that is defined with def or class, and taking whatever the result of that thing is and rebinding it to the same name. When people ask me what a decorator is, you know what I tell them? It's a function that takes a function and returns a function. This is just too much to say. But we're here to discuss why this matters. And I'll tell you why decorators matter and why we need them. Do you commonly affirmatively do something when defining a class or a function in your code? In other words, when you define a class, do you choose as an explicit action to ensure that methods exist? Do you choose as an explicit action to create missing methods? Do you choose as an explicit action to register that class? Do you choose as an explicit action to replace that class? That's a class decorator. In other words, if you look at the data class decorator, it wraps around something defined with class, i.e. a class, and it ensures that methods exist, like init, like EQ, like the repr. If you use functools.totalOrdering on this thing, you can see that it has I only have to define an EQ and an LT, and it can then create new methods. It can add methods to this thing. So every time you're defining a class, if you add methods and you add them in a programmatic fashion, like add in the less than or equal to based on the equals and the less than, that could be a class decorator. Here, it's the case that tools like PyTest do not register the tests by having a decorator that say, oh, this is a test, this is a test. They register them by reading through the source text, or rather reading through the AST and trying to figure out. Actually, it reads through the result of the module. Actually, no, it does do AST transformation, I believe. But it looks through the function that it looks for anything that starts with a name test, which I think is very silly because who knows why this thing has, test as the beginning of the name. But what you could think is something like hypothesis does register this test function within your PyTest framework to take a certain amount of randomly generated test inputs. So you can see another example of, do you perform some sort of registration? Here's an example of a class decorator that does all of these. we define a class A, and we register it in some fashion. We add it to a registry with the name and the author that are set in. We check it to see if it has a method called f, and if it has a method called f, we add in a new method called g. And this allows us to do things like make sure that that method f exists, otherwise we raise a type error, missing method f. It allows us to take this registry and to look at this registry and see, oh, class A was defined, class B was defined, and maybe create documentation from that, maybe generate tests from that. In a very similar sense, a decorator around a def structure basically modifies the mutable parts of a function, which is the doc and the signatures. For the most part in Python, functions are opaque, so we can't change the actual bytecode that's in the function in any controllable fashion. We're not even guaranteed that the bytecode exists. We can't change the source text. We're not even guaranteed the source text exists. And any library that uses the inspect module to perform mutation on Python code by assuming that the source text exists is wrong. You don't really know for certain that source text exists in Python. This could have been Pythonized. There's a lot of ways. It could have been numbudgeted. There's a lot of ways where the source text might not exist in the fashion you expect. Well, because the functions are opaque, you might replace the function, maybe by wrapping it, or you might register the function. And so an example is the wraps decorator takes this function here and changes the mutable parts, namely the docs and the signature and the name. Or we could think of this decorator that takes some function here, registers what its corresponding test is, maybe for some documentation purposes, replaces it with a new function that calls the original function twice, mutates the mutable parts of the function, like the doc string, so that you can see that the doc string now says, oh, this thing is called twice, adds a little bit to the doc string, and that's all that happens. Fundamentally, what a decorator is a pattern where you're defining a bunch of functions or a bunch of classes. And every time you do that, you want to affirmatively perform some operation. And I say affirmatively very carefully because you have to choose to apply the decorator. This doesn't happen automatically. If you want something to happen when a class is created in your code, and you don't want somebody to make that choice, oh, please do this when the class is created, you want it to just happen automatically, then you need build class, init subclass, meta class, you need one of those non-affirmative, one of those implicit mechanisms. If you want to do this explicitly, you want to say, guarantee, and I know I want to make this guarantee that this thing is registered, that this thing is correct, that this thing has methods added to it. That's what a decorator is. And so if you think about where decorators will come up, anytime you're writing code, we're writing a bunch of functions or writing a bunch of classes, which is probably more than 100 lines of code. And you're commonly doing the same thing every time you define that function. Fix up the doc string. That's how Pandas uses decorators. Wrap it for some instrumentation purposes, logging or timing. Replace it with some function that maybe has some fast path. Register it so that you have some simulation framework and people just write their simulation so it gets pulled into the automatic backtesting framework. Register it so it gets pulled into some testing framework or some documentation framework. Anytime you're commonly doing the same thing, every time you define a function or define a class, that could be a class or a function decorator. That's what a decorator is all about, and that's every use case. That's how they're used. And it's really just about a common operation that you do programmatically on this structure that you choose to do. If you don't choose to do it, if you want it to happen implicitly without you knowing that it exists, for a class, that's another mechanism. As I said, build class, init subclass, meta classes, those are typical mechanisms. For a function, there really isn't a direct way to do that. You need some sort of code transforming mechanism. There's no way to implicitly have something happen every time a function is created within your script without having to intermediate the AST generation and the bytecode generation.